Group 1 elements, valency is 1. Group 2 elements, valency is 2. Okay. P block elements, maximum valency is group number minus 10. Like I have sulfur. Which group does sulfur belong to? Here where your spontaneity is needed. That's what I told you. Remember the 30 elements. The 30 elements should dance in front of you. You should be in a position to pick up immediately. Where is sulfur?
2 minus.
Come again. Come again. Can you repeat, child?
Oh, yeah,
Which
2
group number? Which group number?
6th group.
No.
Ah.
16th.
Yes, it's 16. It's not 6th group. It's 16th group. Minus 10. So what's the maximum valency of sulfur? That's where you see formation of SF6. And what is the minimum valency? So the other maximum valency is this. Minimum valency will be number of electrons gained. So it will be minus 2. I think this is what you were answering me. Right? I heard
Yes.
someone saying, I got it. I heard that. So this is what you were answering me. This is a minimum valence. See, when it comes to P block, you will not have a unique single valence. You will have multiple valences there also. So maximum is group number minus 10. Minimum is number of electrons gained. Okay, in case of non-metals. Transition metals, the maximum valency is N-1 d electrons plus Ns electrons. It will not be applicable in every case. Is it clear? That we will, address this in D and F block elements when we do in class 12. But like, for example, if I take manganese, it's 3d5, 4s2. So you add up the d electrons and s electrons. That will give you the maximum valency cell. Okay. And what did I tell about F block? Which group do they belong to? Which group do they belong to? Group? Yesterday we did it.
The block is lanthanoids and actinides.
Had you noted that, it will be easy. See, I will share the notes, but believe me, the way you take it up during the class is more important because every point, minute detail may not be there in the notes. It's very important that you address to these issues. So this is I told you, particularly the group number is important for F. Which group? Group?
Third group.
Third group, good. So what is the electronic configuration for third group? N-1, D1, NS2. So add the what did I say for this third group? From third group to 12th group, add up the D and S electrons. The valency will be 3. Okay. The common valency will be 3 for F block elements. This again, you will address this in D and F block elements in class 12. Okay. Clear? Then the last is a diagonal relationship is something that I want to take up. This one is anomalous properties of second period elements. It's very important. Yeah. This is the last segment. Anomalous behaviors. I just want you to observe this. What are the second period elements? Quickly. It should go in a flow. That's why I tell you, keep the periodic chart in front of you all time. So you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is enough. Don't include neon here. So these elements, if you see the behavior, so second period elements, if you observe, will be the first member in the respective group. Am I right? Do you agree? Means every group is beginning. Like lithium onwards, your alkali metal starts. Carbon onwards, the 14 group element starts. Nitrogen onwards, the 15 group element starts. So the first member in the respective group will have an enamel as a unique behavior, a different behavior compared to the rest of the elements. Okay. So this is due to, we will give the reasons as two sets of reasons here. Observe this carefully. When it comes to lithium and beryllium, the factors responsible for this is small size, high ionization enthalpy, high polarizing power. Polarizing power is charge to size ratio. So due to these reasons, what will happen? Lithium is different in its behavior compared to its group elements. Like sodium, potassium and all, they behave in a different way. Lithium is behaving in a different way. Surprising, lithium resembles magnesium more than its own group elements. So, can you see? This is what is called as a diagonal relationship. Lithium is diagonally similar to magnesium. That's a diagonal relationship. Why does it happen? Because of the following reasons. Same, beryllium resembles aluminium more than its own group elements. Okay, because of the small size, high ionization enthalpy, high polarizing power, so on and so forth. Okay. That's as far as lithium and beryllium is concerned. Now, when it comes to the anomalous behavior of boron, carbon, nitrogen, oxygen, fluorine, these are differently because they belong to the P block, whereas lithium and beryllium belong to S block. The behavior is different. The anomalous nature, you can take one of the reasons, whatever is listed up. One of this could be triggering the anomalous behavior of boron, carbon, nitrogen, oxygen. One is small size, high ionization enthalpy, then high electronegativity. So electronegativity is something, it's a term I can use for non-metals. I cannot use for metals. Because metals will never have a tendency to gain electron. Metals will have a tendency to only lose electrons. So that's why we didn't use this term electronegativity in the first section for lithium beryllium. But for boron, carbon, oxygen, all this, I can use the term high electronegativity. And importantly, absence of d orbitals. We will see this, when I do a little bit of bonding, and you'll be definitely addressing this in the respective groups when you study. Was that clear? So this is called as a diagonal relationship. Okay. So with this, your chapter discussion mainly is done. So we'll move on to your... Okay. Yes. So let's do the first question. Assertion, reason. So there are two statements. Okay. So elements beryllium, antimony, arsenic, tellurium have characteristics of both metals and non-metals. Keep your periodic table in front of you, please. Take your books, otherwise keep the periodic table in front of you. That's where you will speed up, because you will be able to relate the position of the elements in the periodic table chart. Yeah. Yeah. So what is it given? So you have to assess, is the statement one true? Is the reason true or false? Then answer your question. Take the options A, B, C, D. Beryllium, antimony, arsenic, tellurium have the properties of both metals and non-metals.
Answer is C.
Come again?
C.
C. Do you think assertion is true?
Yes.
Anybody else?
No, ma'am.
It is
No,
true.
ma'am. No, ma'am.
Why not?
No.
Do you have your periodic table chart in front of you? Is there any element which is not having the characteristic of both metal and non-metal in that? I told you in the periodic table, where are the list of metalloids? Where is it placed? Everything. Any exception?
Ma'am, I guess here beryllium is the metal, while the others are
You don't have to guess. It is. It is a metal. Okay. Did we not say? Beryllium is what? It's an alkaline earth metal. And don't you see the first element is given as beryllium here? That's it. Your statement is ruled out. So what's the answer now?
D option.
Yes, the answer is D. Next. Which has highest ionization enthalpy?
Option D.
Right. What? Obvious. It's a. What is neon?
Noble
It's in a
gas.
gas. Isn't it? So that's obvious there. Next. The third one I am not going to answer.
B
You're going to tell
option.
me. Yeah. Remember we did this? 23. Next.
A option.
Why? Anion is greater than neutral atom, and neutral atom is greater in size compared to the cation. So, can you relate? Are you with me, students? Any doubts on this? Yes. Sixth period contains 32 elements. So successive electrons enter the orbitals of
D option.
6s, 4f, 5d, 6p. You see all this in the sixth period. You're keeping your textbook in front of you, your periodic table chart in front of you. Believe me, solving this will become very easy. See, first learn to see the book, learn where is what and try to answer. Next comes is how to do it without seeing or learning it. Because this will give you an experience. What type of questions are asked? Next.
C option.
Yeah. Sixth one. Size of anion will be greater. Remember, we discussed this reason yesterday? Because there's a repulsion as well as there is a effective decreasing. Identify amphoteric, which will have an amphoteric nature. Which among this? What type of amphoteric nature?
Aluminium oxide. It shows both basic and acidic properties.
Very good. Next. Sir, how about calling out some students because I'm getting answer only from one child? Students participate. Okay, that doesn't mean. I mean, I'm sorry because you should be knowing it better. That's the reason. That's why I requested you because I will get used to these children.
Sure, ma'am, no problem. I mean, as of now, I guess, if in case if
Ma'am, C option.
This one, D, it should be selenium only. It's not SER. Okay. Bromine, selenium, Se. It's not SER. They belong to the same period. Yeah. Yeah, come again. Option. Check the C option. Someone said C, I heard. Did someone prompt C, students?
Yes, ma'am, I said that.
Yeah, okay. See, how are these elements arranged in the period? Phosphorus, sulfur, chlorine, in this order, right? Left to right. So what happens to non-metallic character across the period? Increases or decreases?
It increases.
That means P is less than S less than Cl, no? Look at the order given. Are you getting
Yes,
it?
ma'am. Yes, ma'am.
Are you able to get what's went wrong there? See, first thing first is, whenever such questions are given, no, pick up the elements and you try to figure out the correct order. Automatically, you'll get the answer. Electron gain enthalpy. Bromine less than selenium less than arsenic. Again, I told you, bromine, selenium, arsenic. So what is actually the arrangement of elements? Same way. Arsenic, selenium, bromine. It's just below this. If you see. Phosphorus, sulfur, chlorine. Just below that is arsenic, selenium, bromine. So what happens to electron gain enthalpy? So when we mean the electron gain enthalpy, it's a negative electron gain enthalpy will increase. So arsenic should be less than beryllium, selenium less than bromine. First one is obviously wrong. Going down the group, metallic character increases. Right? So what should be the order? Don't worry. Let's discuss every option. You will get the answer finally. Sodium, magnesium, beryllium. Look at the positions. Across the period, metallic character decreases. Down the group, metallic character increases. So which is most metallic? See this? It should be sodium greater than magnesium greater. Isn't it? Greater than beryllium. Are you able to get it? Is that clear? So when elements are given like, different period, different groups, see, figure out the position and use our, the trends this way. You will get the correct order. Are you able to get the way I'm working? So now, option B. What do you mean by reactivity? What do you mean by reactivity? So when it comes to reactivity, understand this. With respect to metals, reactivity means electropositivity. With respect to non-metals, reactivity means electronegativity. Keep that in mind, always. When you say reactivity is increasing for non-metals, means electropositivity is increasing. I'm sorry, for non-metals, electronegativity is increasing, and for metals, electropositivity is increasing. Because metals will lose electrons. So, you try to figure out now. Is this right? Yes, no?
Yes, ma'am.
Yeah. Isn't it electropositivity is increasing down the group? So reactivity increases down the group. Got it? Eleventh one.
Option C, ma'am.
Option?
C.
Correct. Yeah. 12th one is also direct. I
B
give you.
option.
Ma'am,
B
one request, ma'am. Sorry.
Tell
Ma'am,
me, sir.
yes, ma'am. One request is 1 second.
Someone who said, gave me the option. Option C. How is it? All the orbitals in the valence shell are completely filled by electrons. These are the properties of noble gases. What is the configuration of noble gas? What's the configuration of noble gas, children? Unmute yourself and answer. Evelyn. I mean, I can see you prompting.
Ma'am, they have filled valence shells.
What is the configuration, dear?
Ma'am, helium is 1s2, neon is 1s2.
If I ask you noble gases, can you give me one configuration for entire noble gases?
Stable.
Yeah, come again.
Stable. A stable electronic.
They are stable. They are stable. Absolutely, they are stable. What is the configuration of noble gas?
Meaning the last orbit configuration. How do you say, guys?
Outer shell configuration, general configuration. Try to always address this using general configurations. If any, there is no particular element given. When a particular element is not given, always address with the general configurations.
Ma'am, NS2NP6.
Exactly, NS2NP6. So what is this NS2NP6? Is it a completely filled outer shell configuration or not?
Yes, ma'am.
It is. So all the orbitals in the valence shell are completely filled by electrons. Is it true? Got it? Is that clear, students? Is it true or not? So when you say octet configuration means the outermost shell has 8 electrons. If the 8 electron configuration is NS2NP6. And it's very difficult to alter the electronic arrangement by addition or removal of electron. Is it true? Yes. Somebody answered me this, saying that it is stable. I heard this. Someone said that it's stable. Why it's stable? Because this octet configuration completes the outermost shell. So adding electron and removing electron both are easy. We told that electron gain enthalpy is positive. And coming to ionization enthalpy will be highest for inert gases. This proves that removing or adding electron is difficult for noble gases. Exhibit very high chemical reactivity. Is it true?
False.
No, isn't it? They are stable. Stable means they are chemically inert. That's why they are inert gases. Okay, so 11 option is only 1 and 2 are correct. Okay. So go to 12th one. The period number in the long form of periodic table is equal to
Option B.
A.
Ma'am, option A.
Option A.
Did you note yesterday we said about, when we were discussing the features of periodic table, what's the period number is equal to? I would have used one word, valence shell. So what is valence shell is giving you? The maximum n value, principal quantum number value. Okay. 12 is A. 13? Okay, 13th question, sir. I think I'll address this once I do the oxidation state concept. Because some topics are, it's common to other chapters. Is it clear? This alone, I'll address it once I do oxidation state. I'll explain you even bonding also. Little bit of bonding is also needed. We will do that later. Please mark it, students. Okay, so that you will be in a position to answer this once we do how to find oxidation states and the concept of covalency. What's the symbol for meitnerium?
B option.
Option B.
B option. It's there in your textbook if you see. That's what I told you. Coming to 15.
A option.
Yeah. What did we say about acidic basic character across the period down the group? See, look at the positions of nitrogen and chlorine. See, sodium, the same period you have aluminium. Right? Can you relate? Then aluminium belongs to 13th group. Then you have in the 15th group, you have nitrogen in the second period and chlorine. Please relate the positions. Okay? That's one thing. Always keep it in mind. Because immediately when you see the elements, this should flash in front of you. Is it clear? That should be your level of preparation. Which period, which element, which group, everything should flash. 1 to 30 will work on this principle. This is something that you have to keep in mind. Is it clear? So, sodium oxide. So, sodium is where? Extremely to the left. So, is it metallic? So, what will be the nature of sodium oxide? I don't know, if you have studied acids and bases also, you would have known this. Periodic table need not be the only way, but even the concept of acids and bases will also help you. Is that clear? Yeah. So, sodium oxide is? Sodium oxide is it is basic or acidic or neutral or amphoteric. It is?
Basic.
It is basic. So option 2. Al2O3, some time back only we did. What is it?
Amphoteric.
Amphoteric.
Amphoteric. Then N2O,
Neutral.
what do you call N2O as? Anybody?
Nitrous oxide. No?
It is nitrous oxide. There's another name for it. It's called as laughing gas. Just because it's a laughing gas doesn't mean it's neutral. There is a concept for neutrality there. What do you mean by neutral? What's the difference between amphoteric and neutrality? Okay, your final answer is acidic. You got the answer anyway. Without understanding what is neutral also, you got the answer. But my question is, what is neutral? What's the difference between neutral and amphoteric?
Ma'am, amphoteric reacts with both acids and bases. Neutral doesn't react with either of those.
Neither acidic nor basic. Okay? Is it clear? Then another concept of neutrality also we do in acid-base concepts. That's in terms of pH, we'll give a different neutrality there. Here, neutral means there are only 3 neutral oxides. Remember, one is carbon monoxide, one is N2O, and the other is NO. Okay. All other oxides of nitrogen are acidic, but these two are neutral. And the only neutral oxide of carbon is carbon monoxide. Okay. You would have probably answered it because it is not fitting in the other 3 categories. You could have said that that's the only thing neutral possible. Clear? Ruling out the other options. So, but understand this. So, what's the option here? 15 is A. Where the following periodic trends are correct? Is correct. There's only one option here. Is correct.
Option C, ma'am.
Yeah. Option?
C, ma'am.
Yeah. Remember, we have done this. Electronegativity decreases down the group. Ionization potential decrease. Electronegativity, ionization potential, electron gain, enthalpy, all these, what did I say? They are all proportional to the effect. Isn't it? and atomic radius is inversely related to ZL. Clear? So atomic radius, I mean, this is an understanding in case you're stuck up. But if you know this with a rigorous practice, you will be in a position to spontaneously answer it. A quantitative measure of a tendency of an element to lose electron is given by its
C option.
yeah. What quantitative measure? What do you mean by that word quantitative measure? See, there are only two cases you actually measure the value. What is it? Ionization enthalpy and electron gain enthalpy. Because you find how much energy is absorbed, how much energy is released, and we have given the examples saying that so many kilojoules per mole, we gave the positive and negative values. Can you recollect that? I've shown you the values. So like we say, it's minus 328 kilojoules per mole. And this is, 1400 kilojoules per mole. We give the value because value given means it's a measurable property. So that's why we say it's a quantitative measure for tendency of an electron. Similarly, electron is added. Actually, electron is lost in these measurements. When I say electronegativity, electropositivity, these are all tendencies. Tendency, when I say it's a probability. Is it clear? There is no act of actually adding electron or gaining electron or losing electron. So this electron gain enthalpy and ionization enthalpy are measurable. Electronegativity measurement is based on an altogether different principle. I gave you the Pauling scale. Fluorine is 4, chlorine is 3, oxygen is 3.5. It's a different scale. Clear? And here the concept is losing electron. Next, assertion reason. Assertion reason. Mendeleev periodic table had left gap under aluminium and gap under silicon. Okay. The elements gallium and germanium were known at the time of Mendeleev published his periodic table. So tell me, is assertion true, reason true or false? Is it correct that Mendeleev has left the gap under aluminium and under silicon?
Yes,
Did we
ma'am.
discuss this? We call them as Eka aluminium and Eka silicon. Did we mention this?
Yes, ma'am.
Yes or no? Yeah.
Option C.
Were they present at the time when Mendeleev, published this periodic table? No. Had they been existing, he would have directly written that, right? No. Because they were not existing, he left gap in those spaces, wrote it as Eka aluminium and he named them as Eka aluminium. Later, after discovery, they were replaced. But at the time of publishing this periodic table, these were not existing. Because they were all not existing, the concept of Eka came. Okay. So what's your answer? What's your answer?
Option C.
Assertion is true, reason is false. Next, 19th one. Again, similar statements here. Elements
Option
become
D.
more metallic as we go from left to right. Is it true? What happens to metallic character across the period?
It decreases.
So they become more metallic or less metallic?
Less metallic.
So assertion is true or false?
False.
False.
Okay. So as you are reading the statement, please do this exercise then and there. Okay, don't give importance to reading the options and everything. When you do this exercise of, assessing it as a true or false then and there, you will be in a position to generate your answer easily. Elements become more non-metallic as we go down the group. Come on.
False.
How
ma'am.
does non-metallic character behave? How does it go down the group?
Decreases.
Yeah. So what should be your answer for this reason?
Option D.
Okay, for this reason,
Less non-metallic.
so true or false? Simple.
False.
Yes. See, this is one more thing, children, I want you to understand is you're doing correct. But sometimes you have to be very, very crisp in the way you're acting. So put it as simple as true or false. Enough. Don't give more explanation to it. Especially when you're doing in a fast pace, right? We have only 1 minute average time for answering one question. Don't do a lot of analysis there. True or false? You should start thinking that way. Okay, I got your reason. Your reasoning is correct. Non-metallic character decreases down the group. So the statement is false. So which option? Both are false. Anybody having a doubt in this? I hope it's clear. So I hope the chart we did today is helping you out. Next, 20th one. Ionic radii can be estimated by measuring the distance between. Okay, this
Option
actually
C.
comes in the solid. Yeah, option C. What we do there is we measure the distance between the cation and anion in ionic crystals. Okay. Again, look at this. The qualitative measure of the ability of an atom in a chemical compound to attract shared pair of electron is called 21.
Electronegativity.
Yes. Remember the definition we gave? It's a tendency of an atom to attract shared pair of electrons. 22. Answer this carefully. See, whenever you have such things given, identify do they belong to the same group or not? Do they? Beryllium,
C
magnesium,
option.
barium, calcium. Arrange them in the order the way they appear in the periodic table. How is it? Beryllium, magnesium, calcium, barium. So what happens to, come on, which is more acidic?
Beryllium, no?
Yes, beryllium oxide. Basic character, see, ideally, no. We say metal oxides are bases, right? So relatively, which is more acidic? Beryllium oxide. Okay. Non-metallic character decreases metallic character. Basic character increases down the group, acidic character decreases. So, which is more acidic? It is beryllium oxide. Come on, 23.
Option D. ma'am.
Yes. Remember, we gave the range for every period, everything. So, cerium to lutetium. And what is what about thorium to lawrencium? What is it?
Actinoids.
Yes, it's actinoid. What is asked here is a lanthanoid. So it's cerium and lutetium. What is the atomic number of the element which is considered as the last element of the third series of the 3D series?
Option A, ma'am.
Option A, ma'am.
Option?
A, ma'am.
A, ma'am.
What is element? What is element?
Zinc.
Zinc.
Good.
Zinc.
Right. Next. Assertion reason. Again, see the same thing. Qualitative measurement, the same concept, the same statement is coming up here. Qualitative measure of ability of an atom to attract shared electrons is called electronegativity. Ionization enthalpy, electron gain enthalpy, and electronegativity are measurable properties. It's a measurable quantity.
Mom, C option.
Yeah. Option C. Sometime back I told you. Remember, what did I say? Ionization and electron gain enthalpies you actually measure in kilojoules per mole. Electronegativity is what? It's based on a relative scale. Are you getting it? It's not actually measured. The electron is not actually added here. Are you able to get the difference? So, statement 1 is true, but the statement 2 is false, mainly with respect to electronegativity. Got it? Is that clear, students? (26) So, which of the following elements would have a formula R2O3? So when I say R2O3, what does it tell you? What is the first thing you get? What's first information you get from this R2O3?
It is basic in nature, no?
Okay. Anything else? Jerome, I'll give you one more. Okay, just see. I have an element, I have a compound P2O3. I have an oxide P2O3. I have oxide R2O3. I have oxide Al2O3. So everything with the formula X2O3 is R2O3 is not basic. Can you get that now?
Yes, ma'am.
So try to dig out any other information. It's common in this R2O3, in all these formulae. What is common?
Oxygen.
Okay. Anything else? What's the valency of the element R?
2.
Check. How do I deduce the valency?
3.
How do I write valency, students? So how did I get the formula Al2O3? We know aluminium is 3 plus, oxygen is 2 minus. You cross the valencies, right? I believe you all would have learned it. So if I have to find the valency of R, what should I do? What should have been the valency of R? Subscript back. That will become the charge. So what will be the valency of R? What is common in all these? All are R2O3. So what is common here? The valency of R should be
3.
exactly. So which of these elements will exhibit a valency of 3? So which feature of periodic table will give you the valency? Which aspect of periodic table will give you valency?
Ionization enthalpy, no?
The group.
Come on. I'm waiting for this. Can you repeat?
The groups give the valency.
The group number, isn't it? Did we mention? Group number refers to the valency of an element because the valence shell electrons will remain same in the group. Can you get that? So which one will have a valency 3? If you know the group numbers of these elements, you'll know the valency.
Option A.
Come again.
Boron.
Option? Yeah.
Option A.
A.
Boron.
Correct. Boron. Boron belongs to group 13. How many electrons? Isn't it 2s2, 2p1? Some time back I told you, valency is group. What is the valency for p block elements? Group number minus 10. Boron belongs to 13th group, no? Minus 10. I will share you the document, children. That will become easy for you. But simple logic here. Group number will give you the valency. Yeah. Next, 27. Which of the following is correct for first ionization enthalpies? Okay. See what happens to first ionization enthalpy down the group? Okay. What happens to ionization enthalpy down the group?
Decreases.
Yeah, decreases. So which is having highest ionization enthalpy? See the elements: lithium, sodium, potassium, rubidium. It will decrease. Which is having highest?
Lithium.
Lithium. So the order should be what actually? Lithium is greater than sodium, greater than potassium, greater than rubidium. Unfortunately, the answers are wrong. Okay. The options are wrong. Clear? Okay. Ideally, the option should have been rubidium less than potassium, less than sodium, less than lithium. I can put it this way. Or the option A, I will take it as all greater than 7. Okay. So, I mean, analyze this question. Okay. Okay. So, sir, I think I can wind up the class and take the remaining sessions tomorrow. Just a few more questions are there. Please, students, go through right away. I'll send you these documents. I'll send it to sir. He will forward it to you. Okay.